Hi there, welcome to section 2.1, Vertex and Standard Form of Quadratics. This may be something you already did in Math 1, maybe not, it just depends on how far Mrs. Kane got. Essential questions for today: what is the standard form of a quadratic equation? What is the vertex form of a quadratic equation? And how do we switch forms? Now I know you know standard form, that's ax squared plus bx plus c. But let's make sure that we know about vertex form. So, note card number 31, vertex of a quadratic. Graphically, if you're looking at the graph of a quadratic, the vertex of a quadratic is the minimum or the maximum point. So if you look here, this quadratic is opening up and the vertex is right here, which is a minimum point. This quadratic is opening downward and the vertex is a maximum value. Algebraically, how do you find it? Well, you do negative b over 2a, the parameter negative b and a, those parameters, you use those and you get the vertex, okay? And you have to plug it back in and all that. We're going to go over how to do that. Remember, maybe you don't know, maybe this is a remember, maybe it's a brand new. The vertex can also be referred to as HK, which is very common, okay? Okay, I also want to tell you that if a, the parameter a, is positive, you probably already know this, but if it's greater than 0, meaning positive, it's going to open upward graphically. If it's negative, less than 0, it's going to open downward. We're really going to be looking at graphs this unit, so I want to make sure that you're starting to make some connections. Okay, so looking at this is not a note card. I just want you to look at this with me. If I give you y equals x squared minus 2x plus 3, and I want you to find the vertex. Yes, you can type it in your calculator and perform some functions, and you would get your vertex to be 1, 2, or easily you could plug in the Desmos. That's the easiest way. But remember, I'm going to try not to use that a whole lot because I need to get you ready for the SAT and the ACT, where you'll have the graphing calculator. But you do need to know how to do this by hand. So using the negative b over 2a method, you would pull off the parameter b, which is negative 2, and a is 1. So negative 2 over 2 times 1, that'd be negative 2 times a negative, which is positive 2, over 2, which is 1. So that's the x value of the vertex, 1. Then you plug it back into the standard form in the x spots and get the y value. So 1 squared minus 2 times 1 plus 3 would be 1 minus 2, which is negative 1, plus 3, which is 2. So the y value is 2. So x is 1, y is 2. That's your vertex. Also could be h and k. H is 1, k is 2. So here's an example that I want us to do on a note card. This is an example of finding the vertex given standard form using negative b over 2a. So go ahead and pause me, get this written down. Go ahead and write this down too, just if you need to, and we will do this one. Just want to apologize in advance. You're probably hearing the dishwasher or the washing machine or the dryer. My cat's got a little toy that she's running around playing with, so yes, welcome to my world at home. So let's find the vertex using the negative b over 2a method. So we know a is 1, b is negative 8. Ooh, let's see. Okay. And c is 15. We know all of those things to be true. We're good at that. We know how to do that. We did that using the quadratic formula. So that should be like old school, easy for you. Now, I know that the x value of the vertex, also known as h, is negative b over 2a. Should be negative 8 over 2 times 1, which would be 8 over 2, and that is 4. So we know that the x value of the vertex is 4. Okay, now that we have the x value of the vertex, the hard part comes, where we have to plug it back in to these x values and get the corresponding y value. So it'd be y equals 4 squared minus 8 times 4 plus 15. So y equals 16 minus 32 plus 15. Let's see, that would be negative 16 plus 15. So I get the y value, or the k value of the vertex, is negative 1. So my vertex is, I like to write v. V, and it'd be 4 comma negative 1. 4 comma negative 1. So there's a nice pretty version of it for you all on one slide. If you haven't already, finish up note card 32. All right, note card 33 is now moving away from finding the vertex using the negative b over 2a method to what we call vertex form. You guys are used to standard form, but now we know this vertex form right here, y equals a times x minus h squared plus k, where the vertex is hk. That's why I kept saying, let's make sure we call the xh, let's make sure we call the yk. So this is the vertex form. What needs to be filled in? Well, in this spot an A, see the green A, in this spot an H, and in this spot the K. So we get A is the leading coefficient, guys, and H is what we just found in our last example, and K is 2. Now I know we see it right here, but I just want you to be aware that these are just parameters. This A that goes here is the same A that's right here. Now the K and the H aren't up here. We have a B and a C. They are not the same thing. So once we find H and K, using the method that we did in note card 32, we then simply just put those values right here. So we could take this one and we could simply write it in vertex form. A is 1, H is 4, and K is negative 1. So I could write it in vertex form that easy, okay? So pause me and finish up note card 33. All right, note card 34 is examples of finding the vertex if you are given the vertex form. So all of these, as you can see, are in vertex form. The y equals a times x minus h squared plus k. So like right here, a is negative 3. H, this is where it can get tricky. This already has a negative in it. So you would have to change the sign of the thing that's embedded inside the parentheses. I also like to call this ZPP, where we take this parenthesis and we just set it equal to 0. So the H value would be 2, and the K in the vertex form is a plus K. So it'll just take on whatever value it has here. So that's a negative. So I'll go over this again, but the vertex is 2, negative 4. 2, negative 4. The vertex is just HK, guys. The vertex is HK. You don't need A, you don't need B, you don't need C. You need H and K. So remember, the vertex is HK, H comma K. It's an ordered pair. Remember, the vertex is an ordered pair. It's the minimum or the maximum depending on whether it's opening up or down. So let me go back to this. All right, so we take, if you want just a shortcut, you ZPP or do the zero product property or just set that equal to 0 inside the parentheses. So x minus 2 equal to 0, you solve it, you would get 2 for H. And then K is just whatever's sitting over here. If you're given vertex form, it's that simple. So using those instructions, what would this be? What would the vertex be? Well, you ZPP or set the parentheses set equal to 0 and you get 1. And then your K is just what's sitting over there, so positive 4. And so then right here, what would your vertex be? It would be negative 5, 2. All right, negative 5, 2. Pause me and finish up this note card, these 3 examples on the note card. Here's some more practice. This is not a note card, but I want you to tell me, what would the vertex be here, here, and here? We're given vertex form. So if we're given vertex form, y'all, our vertex is HK. It's HK. So what would it be here? Drum roll, please. Let's see if you thought it right. Oh, it's 1, negative 1. Yes, because we ZPP or set this equal to 0, get 1, and then it takes K is just negative 1. I just want you to do an extra step. I know I just said to state the vertex, but this opens downward because A is negative 1 and it's negative. Just remember that for our future lessons. What about this one, number 2? Dun, dun, dun. What do we get here? The vertex is 2, negative 3. Because we set this equal to 0, we get 2, negative 3. And this one would open upwards if we graph it. And what about this last one? Oh, back to number 2, it opens upward because A is 2 and it's positive. What about this one? See how you did. Negative 4, 4. That's exactly right. And it would open upwards. All right. Now, here's where we get into the nitty-gritty, the bulk of the lesson. This is note card 35, example of converting from vertex to standard form. I've got this up here just for reference because we need to make sure that we remember this. To convert from vertex to standard form, you just use simplifying rules to simplify the right side. So look here. We're going to have to write out this binomial twice because that's the definition of something squared. Then we're going to distribute the binomials together. And then we're going to multiply the A through. A is 2 on this one. Remember, A sits right there. And then we just combine like terms. So now I've just taken the y equals that was in vertex form and put it right here. Okay, same thing that was on the slide. I just put it over here. So my steps, you're going to need to write out, you hear Oakland, I don't know if you can hear that, but she's trying to dig a hole in the floor so she can make a comfy spot. It's a dog's natural, like, tendencies, but it's so strange because it's not doing anything for her. All right, so I write out this binomial squared. I write it out twice. And the next step I said was distribute those binomials. I need to leave A just sitting there. Okay? I'm not going to change the value of this. I'm just rewriting it. So I distribute. I get x squared minus 2x minus 2x and then plus 4. Now, I said in the next step, distribute A through, but I'm going to go ahead, or multiply A through. I'm going to go ahead and clean up the inside here. There's some like terms. Now I'm going to distribute A through, or multiply it through. And I'm just using rules of simplifying here. So I multiplied the 2 through, and then I still have the minus 3, and then I just combine like terms. And guys, that is standard form. So this is the vertex form. Vertex form. And this is standard form. They're the same thing. They're just written in 2 different forms. Okay. So pause me and get this one finished. All right, I just wanted to show you on Desmos really quick that they are the same. This was the vertex form, and I can check myself by typing in standard form, and I can do this in y equals on my calculator as well. And if you look, they're the same exact. I can unselect this one, see the red? Select this one back, the blue is right on top of it. I did it right. They are the exact same thing. All right, so that was note card 35. Now here are some more examples of converting the quadratics from vertex to standard form. These are not note card level for you, but I do want you to practice these. So pause me, maybe do it on the back of your note card 35. Practice these, maybe a scrap sheet of paper, and then come back and check yourself. All right, let's see how you did. So we want to write the binomial out twice because that's the definition of something being squared. Then we distribute the binomials. But when we do that, we've got to remember to leave the negative out front with a parenthesis. So we remember to distribute it here in a little bit. So we're distributing the x. We get x squared minus 1x plus 1. And then we have the minus 1 at the end. I'm going to clean up inside the parenthesis set. Now, I have to distribute the negative through the parenthesis set. And I still have the minus 1 out on the end. And then I combine like terms. And there is the standard form for that vertex form. Pause me if you need to. All right, now the next one beside it is this. A is 1, so that's going to make our life easier on this one. I'm going to write this out twice. My paper's not wanting to stay in place. Okay, so then I distribute the binomial, and I don't have to worry about a parenthesis when I do that like I did here because I don't have an A to distribute through. So I'm distributing x squared plus 4x plus 4x plus 16, and then still the plus 4 at the end. I'm going to combine like terms, so I get x squared plus 8x plus 20 as my standard form. I could go and type this in the original in Desmos just to make sure that I did it right if I wanted to. All right, I will get pictures of those in here on the slides. There we go. They're all here for you. Make sure that you're checking yourself. Make sure you know what's going on. It's very important. All right, now we're on to note card 36. This is the last note card of the lesson, probably the hardest part of the lesson, because note card 35, we were just going from Vertex to standard form. We just had to follow simplifying rules. Now we have to know how to multiply and things like that, distribute, but that's all we had to do. For note card 36, we're going to have to remember more things, okay? You're going to have to remember how to do it. And I'm going to show you two ways, and I don't really care which way you use. You're going to find that you have a preference. Just use the one that you prefer. So on your note card, I want you to write the converting steps. To convert, you're going to find the parameters A, H, and K, right? Isn't that what we need? If we go back to, let's see, it was slide number 5 in here, which is note card 33. That's what we needed to find to do Vertex form. So if we can just find A, H, and K, we're good to go. Now look at this. A is 1. We already know A. So then we can just use the process I showed you. Let's see, where was it? Oh, it was note card 32. We can just use that process of the negative b over 2a and find h and k, and you'll be golden, okay? Or you can do the complete the square way, which is from section 1.6, which is why I spent so long on it, because I think you guys are going to prefer the complete the square way. So, anyway, so I referred you to which note card you need to go to and all of that for the first way, or you can just complete the square. I'm going to go over both ways. So go ahead and pause me, get all of this written down that you can, and you probably are going to need to go to the back of your note card to actually do the math, okay? Because this is this other stuff that I want you to have on it. So again, I want to remind you, we're taking this that's in standard form, and we want to rewrite it in vertex form. So vertex form, so you're going to write VF is y equals a times x minus h squared plus k. And we need a, h, and k. All right. So in this one, we know a is 1. That's great. We already know a. So using the negative b over 2a way, we also need b. So I know h, that's the x value of the vertex, is negative b. I don't know why I wrote that. Okay, negative b over 2a. So negative 8 over 2 times 1. 8 over 2 is 4. All right, k. To get k, we have to plug back in. Okay, plug that h, that x value, because remember that's the x value. K is the y value. Plug that back into these x spots. So I get 4 squared minus 8 times 4 plus 15. Yes, this is the same one we did. I just wanted you to see the connection. So we get negative 1. So we get that our vertex is hk. So it is 4, negative 1. This is h, this is k. We know a is 1 already. So then all I've got to do is plug into the parameters. So I get y equals a times x minus h squared plus k. Now, yes, I know some things are understood, but I wanted to emphasize that I'm plugging straight in to this vertex form. So then, of course, it's understood to be a 1 in the front, so I'm going to leave that out. And I just wrote it. Okay, so I'm going to have x minus 4 squared, and then yes, I know overall that would be minus 1. So the corresponding vertex form of this standard form is this. So that's the negative b over 2a way. Pause me and write that down. All right, so now I'm going to do the complete the square way. Again, I am not going to have a preference. I am not. But there are going to be some questions where they're going to make sure you know how to do it both ways. Okay, so I'm going to take that same, let me just rewrite it. Y equals x squared minus 8x plus 15. Okay, that's standard form. So to complete the square, now in section 1.6, we learned how to solve a quadratic, which was equal to 0, like find the x-intercepts by completing the square. This is just completing the square. We're using completing the square to write vertex form, okay? So we need to drop the y, toss the 15. Drop the y. Imagine you are setting it equal to 0 and toss the 15 over the equal sign. It would be a negative 15. Now we complete the square here. We know how to do that. Well, you should. So I'm going to rewrite this negative 15 smaller, so because I'm going to run out of room here. So negative 15 plus the square, because remember, what you do to one side has to happen to the other. So how do we complete this square? We take half of b and we square it. So that would be negative 4 squared, which is 16. So that's what we add to both sides. So this is me completing the square. And I've got to remember to be fair, so I had to add 16 to the other side. Now we factor the left side, just like we were doing in section 1.6. So we created a perfect square trinomial, and we factor it. So remember, that's whatever half of that was. So half of negative 8 was negative 4, so it goes right here. And then we add the right side, or simplify the right side. And so on the right side, we get 1. Now, if we were actually solving, finding the x-intercepts, we take the square root of both sides, yada, yada. But we're just rewriting it. So what we do now, once we have it written as a binomial squared equal to a number. So a binomial squared equal to a number. That's not just a hashtag. That's the pound symbol. It stands for number, just so you know. You probably already knew that, but I just wanted to say that. So once I have that form, I'm going to introduce the y back and toss that constant back over. So it would be a negative 1. And does that match? It sure does. The other way we did it, we got the same exact thing. You're going to find that you're going to have a preference. And again, it does not matter which way you prefer. It doesn't matter. But you need to be aware and know how to do both ways. Pause me and get this written down. I had to create another slide. So that you could see this. So here we go. This is what I just went over. I just dropped in screenshots. Now I know it has that little plus in it, but I think you'll be all right. And that's a lot. So yes, that's the last note card of the section, but I've got some more for you to practice. So on a scrap sheet of paper, on another note card if you want to, and staple it to that note card, something for you to practice how to do this. I will have these worked out in the next few seconds and put them on here for you to check yourself. But for right now, pause and try these. So I went in and manipulated these slides because I know I had all 3 of these practice problems on here. So here's the first one. Here's the negative b over 2a method. Okay, went through all the steps. And here's the complete the square method. And I just want to go over that another time with you because I think this one's a little more straightforward. We act like we're setting it equal to 0. We drop the y. We toss the constant so it became negative 5 over an equal sign. We have to add a square to both sides because we can't forget that what we do to one side we have to add to the other. So we need to complete the square. I take half of b and I put it right here. That's negative 1. That becomes a binomial squared. Then I square what that is, and that's a 1, and it goes here and here. Clean up the right side, get negative 4. Once you have it in the form of a binomial squared equal to a number, you toss it back over, and you have your vertex form. See? They match. The second one, here's the negative b over 2a method. You plug into negative b over 2a, then you get x or h is equal to negative 4. You plug it back in, and you get that y or k is 2. We know a is 1. So then we just plug into the vertex formula, and there it is. Or we can do the complete the square method. We toss the constant over the equal sign. There's a negative there. It may be hard to see. And then we complete the square. So we take half of this number, which is 4. It goes right here in a binomial squared. You square it. Go 16 here and here. Clean up the right side. You get -2. We have it in the form of a binomial squared equals a number. Toss the number back over. There you go. And look, they match. Third one, right here. So here's the -b/2a method. Here's the complete the square method. So we set it equal to 0. Well, actually, you're pretending that you're doing that. You drop the y, toss the constant, -3 over the equal signs. That's why it's -3. Add a square to both sides. You take half of this, which is 2, a +2. It goes right here in a binomial squared. And then you square that. You get 4 and 4 here. Clean up the right side, you get 1. Once you have it in the form of a binomial squared equals 1, toss that back over, and you get this vertex form, which matches that one. Again, pick your favorite way, but you need to be aware of both ways. Remember, over here, the -b/2a way. -b/2a, we get -2 for h, which is the x value of the vertex. Plug that back in to get y or k. Be careful when you're squaring the negative, because when you square -2, it becomes a +4. Then right here, a -8 plus 3, I just combine like terms to get -1. And then a is 1 from the beginning. Plug back in a, parentheses, x minus h squared plus k. I know that's hard to see, guys. This becomes a positive, a negative, and a negative is a positive. And that's plus a negative, so that's a negative. Good job. If you made it this far, you need to send me an email saying I made it to the end of the 2.1 video for 2 extra credit points on your checkpoint this week. Thank you for paying attention. Thank you for doing what you're supposed to be doing. These videos are so important. Please be sure to rewatch them if you need to. That's part of the learning process. I hope that you have a great day. Bye, guys.